Good afternoon, students. How are we doing? And I hope we've been keeping well, especially during this tough and trying times of this corona period. I hope we've been keeping to the rules, the health measures being outlined by the health experts. I just want to reassure us that everything will be fine. Yes, things will definitely get better soon. So just hanging on, or rather hang on, and then do the necessary precautions you have to take, believing that soon we'll get past this. I'm sure and I'm persuaded that it will end in praise. Okay, so officially we'll be starting our second semester, and I believe for the course statistics, we've not been able to have the first semester exam, but not to worry. At a much more appropriate time, arrangements will be made for those exams to be written. And I also want to believe that by now we must have gone through the course outline that I uploaded on the my CCU space. So if you've not, please do well to go download the course outline and gather other text, other materials. I think I've uploaded up to 3 materials. So please do get them, download them, and then go through them. Are we following? So now, for this semester, if you remember last semester, we did more of, what's it called? We did more of inferential statistics. This semester, we'll be doing hypothesis testing and some other forms of statistics. And to start the semester, we'll be looking at correlation analysis. We'll be looking at correlation analysis. Now, to an average individual, when we mention the term correlation, I'm sure this is not the first time we'll be hearing the word correlation. We'll be hearing correlation. What does it mean? What does the term correlation really mean? Now, when we talk of correlation, correlation simply means the relationship between two or more variables. I'll take that again. Correlation simply means the relationship between two or more variables. Now, is it a positive relationship or a negative relationship? When two variables, let's take for example, height and weight, the height of individuals. Let's say you gather 10 individuals and you measure their height and you measure their weight. Now, if there is any form of relationship between their heights or their weight, we refer to that. We say there is a correlation between the heights and the weights of these individuals. Are we following? We say that there is a correlation between the height and the weight of these individuals. Now, the kind of correlation that exists between these two variables, which is the height and the weight, is also another factor that needs to be determined. If, let's say for example, when the height was increasing, the weight also increased, we can say there is a positive correlation between the height and the weight of this individual. On the other hand, if, let's say, when the height is increasing, let's say 5 inches, 10 inches, 25 inches, or if you are to measure in foot, let's say 5 foot, 10 foot, and so on. Now, if the height is increasing and then the weight of these individuals is reducing, in such a situation, we say what? There's a negative correlation between the height and the weight, or between the two variables. Now, there are various ways of detecting correlation in a particular data that has been given. There are various ways. We could use what we call the scattered plot diagram, which we are going to look at. That is one. We could use, secondly, what we call the Capes-Pearson coefficient correlation. And thirdly, we could use what we call the rank method to derive correlation. I'll take that again. Basically, for your level, we're just going to look at 3 ways of detecting correlation between two variables. One is the use of what is called the scattered plot diagram. 2 is what we call the Cow-Pearson's coefficient correlation. And 3 is what we refer to as what? As the rank method. So any of these 3 could be used, and we are going to look at them one after the other. And the first one, or rather, before we now move into looking at these things in depthly, I would also like us to look at the types of correlation. The types of correlation. Basically, there are 2 main types of correlation. There are 2 main types of correlation. The first one is what we refer to as the positive or negative correlation. The positive or the negative correlation. And then the second one is what we refer to as the linear or the non-linear correlation. The linear or the non-linear correlation. So I'll take the 2 again. The first one is the positive and negative correlation. That's 1. The second one is the linear and the non-linear correlation. That is 2. Now, the first one being the positive and the negative correlation. We can say 2 variables are either positively or negatively correlated when, for example, if an increase in one variable brings about increase in another variable. Let's take, for example, we are looking at 2 variables such as costs of production and revenue. Now, if when your cost of production increases, the amount of revenue you gain increases, we can say there is a positive relationship between your cost of production and your revenue. On the other hand, if when your cost of production increases, your revenue decreases, we can say there is a negative correlation between cost of production and revenue. Another example, let's take demand and price, for example. We all know that the law of demand states that when price goes up, quantity demanded does what? Comes down. That is, when the price of a commodity increases, the quantity as a rational consumer, the quantity of goods that you buy will definitely reduce because your income is limited. So when price goes up, the quantity comes down. In such situation, we can see there is a negative relationship between price and what? And man. Between price and the quantity demanded. Are we following? Now over to the next type of correlation, which is the linear and the non-linear correlation. A set of variables is said to have linear correlation if when plotted on a graph, that is on the L and Y axis of a graph, if you are able to get a straight line, we can say there is a linear correlation relationship. But if when plotted on a graph, you do not get a straight line, then you can say what? There is a non-linear relationship. I'll take that again. When you plot the relationship between 2 variables on a graph or on a chart, if you are able to get a straight line, I'll still come to a much more practical example in the next slide. If you are able to get a straight line, we say there is a linear correlation between the 2 variables. Are we following? Now, if you are unable to get a straight line, we say there is a non-linear correlation between the 2 variables. Are we clear with this, please? So now, having said this, now let's look at the various ways of detecting correlation which I've mentioned, the various methods. Remember, I made mention of the fact that there are 3 in number. One is the scattered plot diagram. Another is the Cow-Pearson's coefficient of correlation. And then the third one is the rank method. So the first one we are going to be looking at is what we have on our screen right now, which is the scattered plot diagram. Now, in the first case, as you can see, where it says moderate positive correlation, you can see that when plotted on the y and the x axis of this curve, that is for the first diagram, we can see the kind of relationship it has. It shows that there is a positive correlation here. However, it is a moderate one. On the other hand, we could see that there is a strong positive correlation for the second one. And then for the third one, there is a perfect positive correlation. And on the fourth one, there is a negative correlation. On the fifth one, there is no correlation at all. And on the last one, there is non-linear correlation. So when you're able to plot variables on the x and the y axis, on the y and the x axis of a particular thing, if you are able to get so look at what I'm saying. Let's take, for example, this is the y-axis and this is the x-axis. This is the y-axis and this is the x-axis. Now, when you plot, let's say on the y-axis here, you measure height. On the x-axis, we measure the weight. If at the end of the day, if what you are able to get leads to something like this, it means there's a moderate positive correlation. When it leads to something like this, we say there's a strong positive correlation. You can see that the values are coming together. When you something like this, we see there's a perfect positive correlation. And if you're able to get something like this, you can see it is sliding from the left down to the right. So in this case, we see there is a negative correlation. In this case, because the diagrams are scattered, we could say there is no correlation at all. And in this case, there is a non-linear correlation. Now, the next thing we are going to be looking at, let's look at a much more definite example. Let's say you're given a data like this. And on this data, let's say you're given the number of students on this column and the amount of books these students purchase at different semesters, in different semesters. Are we following? This is the amount of students. This is the amount of books they purchase. In their first semester, 36 students purchased 31 books. In the second semester, they had 28 students. And out of these 28 students, 29 books were purchased. In the third semester, there were 35 students. And out of these 35 students, the school library sold 34 books. And now, in the fourth semester, they recorded 39 students for that course. And out of that 39 students, 35 of them purchased books from the library, and so on and so forth. Now, with the help of a plot, of a scattered diagram, we could show the kind of relationship that exists between the students and the amount of books sold by the library. Now, let's say on the y-axis here, we measure the amount of books sold. On the x-axis, we measure the amount of students. Now we could see that in the first semester, where they had 36 students, 36 could be positioned somewhere here. This is 36. The amount of books sold was just 31. So 31 books is positioned somewhere here. This is when the amount of students was 36, the amount of books sold was 31. When the amount of students were 28, which is this, the amount of books sold were just 29, which is this. When the amount of students were 35, this is 35. 35 should be somewhere here, at the middle here. So the amount of books sold were what? Were 34. So at 35, we recorded 34 amount of books. So we placed the dot here. When the amount of books, the amount of students were 39, the amount of books sold was 35. So 39 should be here. We trace it up down to 35. This is what we get. When it was 30, we trace it up to 29. At 30, this is 30. And we trace it up to 29. This is it. At 30, when there were 30 students, 30 books were sold. So 30 students, 30 books were sold. 31 students, 30 books were sold. So this is 31 students. 31 should be here, at the midpoint here. 30 books were sold. So you can trace this down, and so on and so forth, even up to the what? Up to the last one. When you were 29, when you were 26 students, just 26 books were sold. This is 26. You can see 26 books were sold. So this is how to plot the scattered plot diagram. And now looking at these variables, you can see that we can draw a straight line like this. When you trace that line downward, let me use this. So you can see this straight line. You can try drawing a straight line. When you trace it down, you can see that it shows that there is a linear relationship, because a straight line could be derived. So there is a linear relationship, and it also shows that there is a positive relationship between the amount of students and the amount of books sold. Now the second way of deriving correlation, which is the Pearson's correlation coefficient. Under this, we could see the formula. This is the formula for the Pearson's coefficient of correlation. And mind you, this correlation was coefficient correlation was derived by the popular statistician known as Karl Pearson. That was why it was named after him. That is why it is called the Pearson's coefficient of correlation. And it is usually denoted by the term, this R. Although it is not called R, it's a Greek letter called rho. Rho. We follow. So this is the formula for deriving the Pearson's coefficient correlation. It is what? N, which is the number of variables, multiplied N into summation xy minus summation x into summation y divided by the square root of N into summation x squared minus summation x raised to the power of 2, N into summation y raised to the power of 2 minus summation y squared. And now let's look at a much more practical example. But before we go into an example, let me explain the fact that the interpretation of Pearson's correlation the interpretation of Pearson's correlation coefficient varies. Now, after solving the Pearson's coefficient of correlation, you could get values that ranges between -1 to +1. Are we following? Your value can fall between what? -1 to +1. Now, each of these values has a significant meaning. The closer your value is to 1, the stronger the correlation. When you get a value that is close to 1, it shows that there is a strong relationship between the two variables. That is, when you're able to get a value that is close to 1, it shows that that there is a strong correlation between what? Between the two values. Take for example, if you get a value like 0.8 in your Pearson's coefficient of correlation, it shows that there is a strong positive correlation. On the other hand, if you get a value that is close to 0, let's say you get a value like 0.1, 0.2, 0.3, it shows that there is a weak correlation between the variables being looked at. Now let's do a much more practical example. Let's take, for example, you're given a data like this. You're given a data like this, and this data shows the age and then the height of a group of students. It shows what the age and the height of a group of what? Of a group of students. Now you have to examine if there is any relationship between the height and the age of these students. That is there a positive relationship or is there a negative relationship? Is there a linear relationship or is there a non-linear relationship? Are we following? Now to do this, remember our Pearson's coefficient of correlation formula. The first thing you have to do is to arrange this set of data just the way it has been arranged as we have here. The age becomes your X variable, while the height becomes your Y variable. And now, the next step you have to take is to multiply your X by your Y. That is 43 times 99 will give you 4259. 21 times 65 will give you 1365. 25 times 79 will give you 1975. 45 times 75 will give you 3150, and so on. Now, the next step is to take the square root of this. That is X raised to the power of 2. So 43 raised to the power of 2 will give you 1849. 21 raised to the power of 2 will give you what? 441. 25 raised to the power of 2 will give you what? 625. 42 raised to the power of 2 will give you 176, and so on. And the next thing you have to do is to look for what? Y raised to the power of 2. And when you do that, you get these values here. 99 raised to the power of 2 will give you what? 9801. 65. So you do the same thing for the height. You raise every value here to the power of 2. Now you get a summation of them all. Summation xy will give you what? Summation xy will give you, when you add all this together, it will give you what? 20,485. When you add all this together, it gives you what? 11,409. When you add all this together, it gives you what? 40,022. When you add all this together, it gives you what? 486. When you add this together, it gives you what? 247. Now, you write out those variables here, and then you quickly substitute. Wherever you see summation x, this is summation x. So summation x is 247. Summation y is 486, which is what you can see here. Are you following? So we substitute. This is your, remember this is our formula. Wherever you see n is the amount of variables we have. And when you count, you can see we have just 6 variables here. 1, 2, 3, 4, 5, 6. So wherever you see n, you add what? 6. And then this is what? Summation xy. This is summation xy, which is 20,485. You place this here. And then you substitute. Wherever you see summation x, which is 247. Summation x, 247 squared. Summation x squared 247 here. You place it here. Summation x again, which is here, you place it here. Then solution y, which is this, 486, you place this here. In the equation again, we also have solution y here too, that's 486. So you place this here, raised to the power of 2. When you work this out, it will give you 0.529. That is, when you multiply this, you minus and everything here, it will give you 0.5298. Now, what does this tell us? We have to return back to our coefficient correlation. Remember, we told us that the closer your value, the R value, which is your coefficient of correlation value, R is your coefficient of correlation. The closer R is to 1 or minus 1, the stronger the correlation. The closer R is to 0, the weaker the correlation. So look here, the value we got here is what? 0.52. This is closer to 1, 0.52. So, and as such, we can say that what? That there is a moderate positive correlation. Assuming we had a value of minus 0, we can say there is a what? There is a negative, there is a moderate negative correlation. Are we following? Assuming we got a value of 0. Let's say we got a value of 0.8, we can see there is a strong positive correlation. Assuming we got a value of minus 0.8, we can see there is a strong negative correlation. Are we clear, please? Okay. So this is the second example. This is the age and the weight. We do the same thing. This is the weight, and this is the age of the people, and this is their weight. So we do the same thing. Remember, x, our age is our what? X variable, our y is our what? Weight. So first thing you have to do is to multiply what? Your x and y. 8 times 98 will give you 782. 2 times 74 will give you 148, and so on. Now the second one is to do what? Is to get x raised to the power of 2. 8 raised to the power of 2 will give us 64. 2 raised to the power of 2 will give us 4, and so on and so forth. Now we have y raised to the power of 2. 98 raised to the power of 2 will give us what? 74 raised to the power of 2 will give us 5476. 87 raised to the power of 2 will give us 7569. 82 raised to the power of 2 will give us this, and so on and so forth. Are we following? So we write out all these variables out here, just like we did before. You substitute them. When you substitute them, you will get what? And then when you substitute them into the equation, remember we have just 5 variables, which is 1, 2, 3, 4, 5. Okay. Remember we have just 5 variables here. 1, 2, 3, 4, 5. And when you add all this together, it gives you 22. When you add all this together, it gives you 413. When you add all this together, it gives you 1926. When you add all this together, it gives you 124. And when you add all this together, it gives you 34557. So you substitute those values into this what? Into this your formula. You substitute them into this formula. When you substitute it into this formula, and then you solve. 5 is n. Summation xy is what? 1926 minus summation x, which is 22. Summation y, which is 413. Then you take the square root of this all. N again, which is 5 and 2. And when you solve all this down, you get a value of 0.99. Now a value of 0.99 shows a very strong positive correlation between both variables. Hence, you can summarize by saying what? This shows a very strong positive correlation between both variables. Now I've given us examples to try our hands on, and I'm expecting that before our next class, you would have submitted your answers. I mean, you would have submitted this assignment. So this is the cost of production, and this is the profit that a particular company earns. So looking at these values, try to see if there is any correlation between the two values. Second assignment is use this data and then plot the scattered plot diagram. The plot diagram, that is what we did here, something similar to this, what we did here. This is an example of a scatter plot diagram. So plot that with this data, and then tell us if it is a positive correlation or if it is a negative correlation. With this, I think we've come to the end of today's lecture. Please feel free to ask me questions. The WhatsApp groups have been created. It's a platform for us to get to interact. So if there is something you don't understand, please feel free to ask questions. I'm begging you, I would appreciate every form of questions you have. I'll take my time to personally attend to each and every one of these questions. So feel free to ask. It doesn't matter what kind of question you think. You might be thinking, okay, wouldn't they think this question is dumb and all that? Please, there is no dumb question. The main idea is for you to understand the concept. So please feel free to ask questions. I'll be expecting your questions. You can leave questions for me on the WhatsApp group that we've created. You can private chat me on WhatsApp. My email ID is on this PowerPoint. You can also contact me through that. And you also always have my phone number. Get it from the WhatsApp group too. Feel free to ask questions. Thank you until I come your way next week or in subsequent lectures. Do take good care of yourself and remain safe. Thank you.